Dear BTech and MTech students, today we are discussing about wireless sensor network project. This is based on 2022 best paper, IEEE best paper. So in this, the title of the project is Increase Network of Time, Load Balance and Efficient Routing Model. See, efficiently if you do routing as well as balance the load at every node and the clusters and use the energy in the nodes efficiently, that increases the network lifetime to total network lifetime means wireless sensor network is deployed on a particular area like mining or military applications or wherever it is required. So once it is deployed, it should operate for a maximum period of time, means maybe 10 years, 5 years, like that. Maybe one day it is left to the deployer, means owner who is going to deploy. So for that, lifetime of the wireless sensor network you need to increase. So to do this, how and what are the issues regarding that this project is. So here main thing is to increase the network uptime in wireless sensor network. Every node runs runs with an energy coming from the battery, means every node is going to have its own battery. So batteries actually store the energy, and that stored energy is used in nodes. So these nodes are deployed across the regions. So what happens, each, see, we form a clusters. So in this project we are forming the cluster of the sensor nodes, see, wireless sensor nodes. So cluster and there is one node called cluster head. This cluster head will collect the sensed information from all the nodes within the cluster. You can see the diagram. See this circle. This represents one cluster. In this cluster, so this center of the node is called a cluster head. It collects the information from all the nodes within that cluster. After collecting it, like joins, what it does, you can say this aggregate collected information. So this node aggregates all the collected information, joins to it, and then transmit to the base station. Sometimes what happens, this cluster it sends directly to the base station only if it is near to that, means directly it is capable of talking to it. So network is established, connectivity established. In some cases it cannot, so it uses intermediate nodes. See, this cluster head uses this and this. These two nodes are used as a relay nodes to transfer. So cluster head of a particular cluster can also act as a relay node. Oh, so this is called a path. This is the path. So choosing the right efficient routing. So whether this can go like this also, it can go like this also, coming to here and then coming to here like this, and sometime coming here, coming in like that. So efficiently we should route this to save the energy. See, transmission, to transmit power is utilized, the battery of the cluster head is utilized. Similarly, to transmit the information from wireless node to the cluster head, so means this within the cluster, node should send in sensed information to the cluster, so there also node uses some energy of it, so it consumes energy. As it consumes energy, battery will start draining. Once the battery level goes zero, automatically node will be disconnected from the network, and it's like it stops functioning within the network. If all the nodes have dried, then automatically network is dead, so it is not hub. So to have a network up for long time, each individual nodes must use the battery efficiently. So to achieve this, we have so many proposals. So you see, there is a cluster head close to the base station. So this is the close to the base station. tends to dry. So means it loses this battery power, because it is not only collecting the information from the nodes within the cluster but and sent to the base station, but also it should act as a relay node for this cluster as well as this clusters. Understands? The nodes which the cluster heads which are near to the base station, possibility for them drying drying quickly is there. So they can dry quickly. The nodes, the cluster heads near to the base station dry quickly. So and also at the distance base station here also. So there is one problem, and another one problem is they can dry because of some forward the base station. So relay nodes also, see, because this is used as a relay node, drying of this is also required. So for that we have some kind of solution what we have decided. So it is an heterogeneous network, means all the nodes are not having the same energy level at the time of deployment. So one node may have 300 say battery capacity is different. Each node is having the battery that capacity is of different CMH. They measure in CMH. I forgot the unit for the energy measurement battery. That's fine. So but they are different. So that's why we call it as heterogeneous. Heterogeneous means battery capacity of the node is not same. Each node may have its own battery and its capacity is different. So solution for this is, so our question is how to increase the network uptime. To solution for this is, see, we decided to have a cluster head is a position, it is shifting. For example, in this cluster, this function as a cluster head. As functioning as a cluster head, it loses energy for three purpose. See, it acts as a relay node, so it loses its energy when it is retransmitting the information received from the other base station. It retransferred to the base station, so it uses energy. Again, it collects the information from the nodes within the cluster as well as transfer. It loses. So like this, so it is drying. As it is drying, once the battery level of this cluster head comes to certain level, we automatically shift the cluster head work to nearby another node, maybe this node, which is in white color. This node will take the charge of the cluster head position, and previous cluster head will start behaving as a simple sensor node within the cluster. So here first thing is we will form the cluster. So you can see, so see there are two types of nodes as we discussed, some with more power, some with less power. Cluster formation based on distance from base station and physical location. See, cluster formation, it is this much far, and this is one cluster. Like this cluster formation is based on distance from the base station as well as physical location, which is newer. And also cluster head is selected within the cluster, means once you have decided the number of clusters, each cluster we need to decide the cluster head. So we select a node that has more energy condition, energy condition, which has energy condition of the node which is having high within the cluster is selected as a cluster head. Means we have to select the cluster head in the cluster, and energy level, the node that has more energy level is selected as a cluster head. It will be dynamic. Why I said it is dynamic? Because during the operation, when we have selected a cluster head, node A as a cluster head, during the operation it started losing its energy level. It starts spending energy for collecting information within the cluster, nodes within the cluster, and transmitting to the base station, as well as it is acting as a relay node for other far away cluster heads. So it loses. Once its energy level starts dropping, maybe within the same cluster, another node that is functioning as a simple node, means simple node may possess more. Initially it was 20 points, this cluster it has 30 points. As the 30 points decreases, it goes below 15. This also maybe still maybe it is holding 18. So 18 will become like this. A clustered position within the cluster in a group of nodes will change. So like this, dynamically we are deciding the cluster head, and we are simulating done slots. Each slot there is a slot. Each slot, all sensors will send the information, and it is aggregated by the cluster head and transmitted to the base station. Sometime it transmitted via relay nodes, sometimes directly. It depends on its position. And relay node selection means that is a path that is dynamic. What we say means, previously it went to particular relay node, but next time that relay node might have lost the energy and it would have become simple node. So, and because of that, path is selected dynamically during every slot. And finally we will come to know what is the lifetime of each node, and automatically we will come to know the lifetime of the network lifetime. So, and here what happens, for the calculation purpose, 1 unit for sensing that and transmitting to cluster head. See, every sensor node will lose 1 unit of energy to sense and transmit to the cluster head, and 2 units is used for aggregating, means all collected information at cluster head. 2 units is used. Cluster head uses 2 units of 2 units of energy to collect the information within the cluster from other nodes and send to the base station. And similarly, if base station is acting as a relay node, during that case it receives the information from other base stations and other cluster heads. It receives information from other cluster heads and transmit to the base station. For that it spends 1 unit of energy. So 3 kinds of energy expenses, and how much energy is deducted is totally based on as what it is behaving. If node behaves as a cluster head, it loses 2 units to collect and transfer. And if node behaves as just a sensor node, it just spends 1 unit for transmitting, sensing and transmitting. If the node acts as a relay node, it also spends 1 unit because it just receives from the cluster head and transmit to the base station. So this project is totally implemented, run in Java simulation, and you could find the complete code on the GitHub link, which we are showing on the screen. Of course, we are going to give this link in a description also, and then I will run the project so that you can make more clarity on this. See. See, it's like this. So I'm running this application for 200 slots, and we need to fix the range, means physical range, x and y axis, to display the nodes. And I will come with 9 clusters. We have 9 clusters in this wireless application deployment, and there are 2 types of heterogeneous nodes. I said no. There are 2 types of nodes. There are 30 nodes with type 1 means more energy. There are 40 nodes which have less energy, means capacity nodes. This is heterogeneous node. Totally we have 70 nodes. Out of 70, 40 nodes have less energy and 30 nodes have high energy. And then transmission range means minimum a node can transmit up to 100 points. And what is the power? Minimum power means 60 units, maximum power means 200 units. And maximum distance that can be sent is 650 units. So these are all the initialization we have to do. And now I will run the project. See. See, you should go to WS sensor, wireless sensor simulation, right click, and you can say run as Java application. send application. This is the way it starts. See, uh, see this is the cluster head, and these are all the normal nodes, and this is the base station. See, this collects the information from this and then transmit via. See, this uses, see, this is a relay node. Information comes. See, this acts as a relay node. See, path is changing when you are sending. So its path is changing. Why path is, you see here base station itself is changing within this cluster, because, and once it becomes red means its energy level is zero, and it cannot connect, or no, it's down, that node is down. Yellow is like it is getting down within short period, and green is the, so we have used three colors for nodes. Green is the full loaded, full charge, and so half charge is spent for yellow, and red for come. So this is the how the simulation works, and then you can see the results here. See, you can see the results here. See, simulation started. Number of nodes is 70, 40 plus 30. 40 are less energy and 30 are more energy nodes. And 800 total power is 8400 units. Means all addition of all the energy in 70 nodes, each have its battery, though all is added together, you will get this. Imagine that slot 0 consumed 91 units power utilized, and you are left with this energy. Total energy is we spent 91, and during this slot 0, no node has dried. Means all nodes are functioning well. See, as goes down, see, as the slots comes down, see, we can see at slot 59, you can see, and dry 40 nodes have dried. Means around 40 nodes have less energy, they have dried. So similar like that. Another, see, in 66 another node 41 dried. So which node dries what time, and when there is some node is dried, automatically if that node which dried is a cluster head, if any information sent to that cluster head will be dropped. So means what is dropped. So like this, it gives all the details which during each slot what is the energy spent, and what is the energy spending, how many nodes are dried and how many are active. This is information first, and as well as we will have a base station report. So that is having like this. Base station has got its own report. You will. This is the project what I am saying. See, this is base station received data. You see, it is simulation started. There are 70 nodes. Total power, number of slots. We have repeated this for number. In slot number, you can see slot. This is the slot 1. This is the slot C. Cluster 8, cluster slot number 0. Class number 0. This is one line for one slot. This is one slot. In this slot, there is a cluster head called 50. Cluster number. This is, if you want any clarification, you contact me. This is the, one second, I will, how many slot 0, I'm looking at slot 1, I want to show, yeah. So you can see slot 1 started here, up to this, slot 1, up to this. So you can see, I will view this as a word wrap. I remove this as a word wrap. See, you can see, there are 9 so you can see it. She's like that. See, there are 70 total list, no? So you can see, there are 9, no? 1, 2, 3, 4, 5, 7, 8, 9. These are the first 9. See, 0, 0, 3, 4, 5, 6, 7, 8. 9. So this is up to 9. See, 9 lines. First lines, it is the information regarding the first lot. In the first lot, there are 9 clusters. See, cluster 1 is 15 is the cluster head for 1, and 12 is the see, what is this? This is the number that identifies the node ID. You can say it is a node ID. Cluster head ID is 15. So therefore, how cluster 15 sends the information, means cluster 0, it sends the information from how many nodes? All the nodes in this cluster. Cluster number 0, cluster number 1, 2, 3, 4, 5, 6, 7, 8, 0 to 8. So totally 9 cluster information is received. Similarly, see 0, 1, 2, 3, 4, 5, 6, 7, 8, so up to this. Slot, yeah, up to this. This is again another 9 plus. See, every slot will have 9 info 9 data received from 9 clusters to the base station. So 9. So in during this case, you can see cluster number 0 added by 15, cluster number 0 added by 15, cluster number 5 is added by 0. See like this. But during the operation, cluster head will change. For a cluster number 8, head is 18. See whether is this cluster number 8? Yeah, it is 18. But this also changes. So I will explain the exact scenarios. If anybody interested in knowing this, means cluster head also changes, and this is like in cluster 0, cluster head is 15, ID is, and this is the information. All the nodes within that is merged together and sent. Sometime it is issued. See, this is like cluster number 3 is little bit far. Cluster it is the number 3, and it is sending the information using the relay node. Information is received from cluster 3 through relay node 15. But here relay cluster 15 is directly connected. Cluster 0 is directly connected, so it received directly. But cluster 5 is indirectly connected. It is connected via cluster. This one. Cluster 3 is connected to base station via relay node. Some clusters are directly connected, some clusters are indirectly. So how they are connected is again decided by dynamically, and you will get the report when this is about this or if anybody interested to know more about this project, they could contact us, and any contact us, as well as if you require any modification for your project, or if you require any modification to your project or simulation, we will definitely undertake. Please look at the screen. You will find our contact number and details for our communication and for your information, and you can contact us for any clarification you require on this project. And you can also download the complete source code from the GitHub, and the link is shown, as well as we will give the link in the description also. Thank you very much. And this project is like increase network uptime by load balancing and efficient routing in heterogeneous wireless sensor networks. Thank you.